Hello, everyone. So today we are on our day 7. Yeah, I'm sorry about being so slow around this. I'm just trying to find topics which are more relevant around DSP. And today I have found something very exciting to me, which is basically handshakes. Handshakes are a way in which politeness is ensured in the world of hardware, and you will see why that is so. You could think of handshakes as a way in which one hardware agent communicates data with another hardware agent, or it communicates control signals with other hardware agent. Um, it's it's the mechanism that's used to exchange data or control between the two hardware agents. In this specific scenario, we will look at data exchange, and we are looking at valid and ready handshakes. So, what are these handshakes? Imagine a scenario where you have an accelerator sitting on the chip. This is the chip boundary, right? You have an accelerator sitting on the chip, and you have a PCIe bus on the chip. And this PCIe bus is basically responsible for routing the data from the accelerator to outside of the chip. You can think of this as more like a co-processing chip that's helping your main CPU in processing some sort of image data or video data or whatever. That's not important. What's important is that accelerator is sending data to PCIe outside of the chip. And the way I mean, the protocol could be very complicated, but I've simplified it here for the sake of illustration of handshakes. So you have a data line. This could be, I don't know, a 32-bit wide bus, and you have a valid bit coming from the accelerator, and you have a ready bit coming from PCIe into the accelerator. And for now, for the sake of simplicity, we assume that both PCIe and accelerator are running on the same clock domain, at the same clock frequency. So, what really happens now? Accelerator needs to send the data to PCIe. Now, the way the accelerator does it, and I'll show you in this timing diagram below. Let's say accelerator has put a data at this clock edge. Let the data be 0xFF something. Let's call it an 8-bit data, actually. It'll be much simpler to illustrate. Okay, so 0xFF, that's the data that the accelerator has put on that bus. And the accelerator, along with putting the data, also adds an additional qualifier which says the data is valid. The data is valid, which means it's not some junk data, it's some actual valid data that the accelerator has produced after some processing. Now, the way PCIe participates in this exchange is by asserting a ready signal. A ready signal. And at this clock edge, let me use a different marker. At this clock edge, where both the valid, sorry about that, where both the valid and the ready are high at this very clock edge, is when the data is taken from this bus and loaded into PCIe. And then from that point on, the data could travel through the PCIe pipeline to the outside of the chip. PCI takes care of that, but we are just looking at the data exchange for now. So you can see that at this rising edge of the clock, the data is picked up by PCIe because the handshake has been honored here. What is the honoring of handshake? The honoring of handshake is basically, for valid and ready handshake, the honoring of handshake happens when both valid and ready are 1 at a pause edge of clock. Basically, that's all it means. Well, in this case, it's a positive clock because I'm assuming that these agents are running at positive edge of the clock. But if it's running on negative edge of the clock, then this statement will change accordingly. Anyways, um, what what does valid and ready really mean in this protocol? As I mentioned earlier, valid is like a qualifier for your data, which is telling that the data is valid and you can sample this data. So accelerator is telling PCIe that it's a valid data and PCIe can actually sample that data and take it out. Now, what is this ready that the PCIe tells the accelerator? The ready is essentially PCIe's way of telling that, hey, I am ready to accept your data and and do whatever I want with it. So when the accelerator sees that both valid and ready are high in this clock edge, accelerator is free to now produce another data on the bus. That's how accelerator knows that it can move forward because the data has been reliably sampled at this clock edge where both valid and ready were 1. Now, same scenario, if the ready was to go low from PCI's side right after this sampling, then this data value will not be changed until the ready goes high again. Since the ready has gone high at this clock edge, right? At this clock edge, that's when the accelerator knows that it can now change the data and put a new data there. And this is the point where handshakes are completing, where both valid and ready are high at the same clock cycle. So what is the philosophy again of valid and ready handshake? It's basically simple. It basically just says that at a given clock edge, if both valid and ready are 1, that's when you can exchange data packets, payloads, or whatever you want to exchange. Now, I want to talk more about the consequences of not having these handshakes. So I think it's a no-brainer that no handshakes means no data integrity. I want to give you a relevant example from life. Imagine you're trying to text a person who is just busy and never replies to your texts, right? In this scenario, what happens? You don't know if they have seen your text because they might have turned off their read notifications. You don't know if your message is received or read, right? You have no idea what has happened to your message, where it has gone. It has probably vanished in thin air. Has it even been sampled by the person that you have sent the text to? So you don't know any of these things, right? And this is exactly what handshakes are trying to ensure that it doesn't happen in the world of hardware, because handshakes make sure that the data is allowed to only change when the handshake is completed, right? So if there is no handshake happening and if you just simply randomly change the data, you don't know if your PCIe is receiving that data or not receiving that data. So that will cause the data integrity issues. Now let's look at some real life applications of valid and ready handshakes. It's mostly used in the high bandwidth on chip protocols like AXI, ACE, Chai. I think I'll talk more about it in the future, but yeah, they're just names. These are some AMBA protocols where these handshakes are used. Sorry. It's used in buffering, it's used in pipelining. These also we'll cover later.